Humans are doing incredible things with data to change how we think, solve problems, and innovate. We're sending people into space to explore new horizons. NASA is generating over 12 terabytes every day from over 100 active missions and thousands of sensors. We're unlocking genome sequences to combat viruses and disease. A single genome sequence with a modest sample size can take up several terabytes. We're using AI, machine learning, and deep learning to create smarter systems and self-driving cars. The problem is that traditional storage systems just can't keep up the performance and capacity requirements for these GPU-powered workloads. This produces inefficient silos, requiring a lot of different touch points and unexpected costs. When you are capturing, creating, and using massive amounts of data, you need the data to be stored and processed fast, while being accessible anywhere it's needed, which is why we are expanding our Dell EMC PowerScale all-flash offerings to include our new blazing fast all NVMe F900 system. Instead of being spread out, data can be stored and consolidated in a data lake. With our latest all NVMe system and a best-in-class partner ecosystem, the most demanding GPU workloads and applications can be handled with ease from the edge, the data center, or the cloud. And it scales out to 93 petabytes in a single cluster, so you can innovate without limits. No matter what your needs are, we can help you from start to finish and beyond, so you can get back to innovating and driving human progress forward. Learn more today at delltechnologies.com/PowerScale.
curious has really helped me to land where I am today. I actually started off as a graphic designer and then moved into motion design, and I'm now a digital fashion artist. I tend to study traditional Chinese clothing and then try find a way to modernize it. I think that kind of fusion between the two is really interesting. I want to find a way to reconnect back to my roots and also share it to my audience. For me, what's interesting working as a digital artist is that there's so many more textures, so many more materials you can play around with. There's a lot of unexpected moments you can find. You could be walking in a park and suddenly something or a shape or a texture catches your eye. Technology is already embedded in my process. I'm able to connect everything into one ecosystem, which means I get to focus on the most important thing, which is the creativity. Everything that I have learned is actually self-taught from online, so there is definitely space for more digital fashion artists like myself to join. Hey guys, welcome to Streaming Thursdays. Hope you guys are doing good. I can't wait to show you guys what I have been researching today. Let's get into it. Usually what I would find, especially during my live streams, is that maybe I'd be showing a technique. Maybe I don't know a certain thing or how to change a color or how to scale something, and someone in the comments will say, hey Steph, why don't you try this? I like to show the raw failings of my learnings.
Damn it, not the right program.
Oh my god. Oh my gosh. Find RS color or just color correct. If you link that all up to your surface, so this RS material blender, connect it to your output surface, you should get something like this, okay? As I get older, I have a better sense of myself, and I feel like right now I'm getting more and more comfortable with my British Chinese identity. If anyone hears about my story or sees my work, at least they will understand a little bit about my perspective and my character.
Human.
Being curious.
Good afternoon, everyone. Welcome to the third episode of our podcast series where we try to address what's next in AI. If you are new to here, welcome to AI Summit 2022, presented by Analytics and AI Unit of Axiata Digital Labs. I'm Pasan. I will be your moderator for the evening. Before we move to today's topic, I will talk a bit about AI Summit, hosted by Axiata Digital Labs. This year's theme for Summit is Metaverse, and our discussions are aligned with how Metaverse and AI drive business growth. Our ADL AI Summit consists of 3 programs. First is an educational series podcast series started on 14th of November, and today is the third day where we try to address what's next in AI. Next is our main event, AI Forum, which will be on 18th and 19th of November. Lastly, we have Geeks Hangout, a series of interactive sessions led by global experts designed to develop AI and machine learning skill sets for data professionals. So coming back to today's podcast, we have a really interesting topic known as Explainable AI, shortly known as XAI, which is expected to enable the third wave of AI systems, where machines are able to understand and interpret the environment they operate, which enables them to make accurate decisions, thus leaving to characterize real-world phenomena. And I want to remind our sponsor for today's podcast is Dell Technologies, and we are happy to have them on board. Coming back on the topic today, we have 2 guests joining with us today. And my first speaker, He received his PhD from the National University of Singapore for his work in computational intelligence. He has applied this knowledge in different domains such as banking, smart cities, renewable energy, and patents, delivering end-to-end solutions to enterprises. Currently, he is working as the lead data scientist at H2O AI, an AI cloud company where their mission is to democratize AI for everyone. Welcome to the podcast, Dr. Vishal Sharma.
Hi, Prasan. Thanks very much for the introduction. Very glad to be the part of the AI Summit, and thank you for hosting this interesting topic on explainable AI, which is very close to the values of H2O.ai and very close to my heart as well.
Thank you for joining with us, Dr. Vishal. So my next speaker, he comes with over 17 plus years of experience in applied artificial intelligence and data science. He has developed winning AI products for multinational companies such as Lenovo, Intel, Microsoft, YouTube, and T-Mobile. And he was recognized as one of the top 40 data scientists in India by Analytics Indian magazine in 2019. Currently, he heads the Subex AI Labs as the head of products. Welcome to the podcast, Zabi.
Thank you so much, Prasan, for the introduction. I think in this session, I'm keen to talk about explainable AI and its importance more from a business perspective. Once again, thanks for inviting. Looking forward for it.
Yeah. So, Zabi, we have seen many businesses are trying to incorporate AI systems into their core business practices. And even end consumers like us will be using these systems as predictions and recommendations. For example, it can be a social media recommendation or a simple weather forecast. And can we really trust the outcomes of these projects? And if not, why are companies so eager to integrate AI into their businesses?
Right. So there are two questions. Let me take one after the other. I think in order to understand whether to trust the AI system outcomes or not, we first need to understand how an AI model works, right? So the models are trained on the data to do a task, right? Whereas the machine learning algorithms helps identify the patterns in the data. In order to do the task can be prediction, forecasting, clustering, or classification. Whereas the data is a everyday observation of our life, right? So we humans have our own biasness and prejudices, and data can encapsulate these biasness and prejudices. When the data is biased, the AI models built on such data can be biased too, right? Similarly, data need to have certain dynamics of future for the AI models to predict accurately, right? Now, when there is no dynamics of future in the data, the AI models tend to fail in certain scenarios and in certain rare scenarios. Now, to your question, can we trust the outcomes of these AI systems? No, we cannot blindly trust the AI systems unless there is an assurance that these systems are built carefully and managed responsibly, right? Now, getting to a second question, like why do companies are eager to integrate AI in their businesses? So we need to understand this. In the past few years, AI has gone through several waves of hype cycle, right? From initial concerns of AI gaining self-awareness and destroying human race to narrow AI applications, beating humans across different industries like gaming to healthcare. We have seen some exceptional results of narrow AI applications across enterprises. So AI hype is turning into reality, guys. See, at the same time, the enterprises are embracing AI in a data-driven decisions and automations. Traditional enterprises are becoming tech enterprises by providing more and more digital services. And AI is expected to play a major role in this transformation journey. So now is the moment while enterprises are want to harness the power of AI, we need to make AI technology more responsible. Hence, there is a need for trust in AI, and explainability plays a very important role.
Thank you, Zabi. So, when we talk about trusting this AI system, a key word that comes up is explainability. So, Dr. Vishal, what is explainability and how does it contribute to trusting these AI systems?
Yes, so explainability, you can think of explainability as a set of techniques which are used to explain the outcomes of machine learning models to end users. So, if you're familiar with this whole process of building machine learning models, so you can be using like interpretable models, such as like some linear models or some decision tree kind of models, or models can be also slightly more complex in nature, so they may render to be like black box in nature. For example, like random forest or XGBoost kind of models, or even neural network kind of models. So in that case, we need to use set of techniques to generate like post hoc model explanations. So for that, for these post hoc model explanations, we use different techniques such as Lime, Sharply. When you're talking about working with image kind of data, then you are using techniques such as saliency maps, etc. So there's a lot of work going on in the research and industry as well to adopt these set of techniques, which are part of explainable AI, so that these models can be explained to the end users, to the business users, and then so that these business users, they have more trust in adopting the outcomes of these machine learning models. So yeah, that is what explainable AI means.
Yeah. That's really interesting point of view. So Zabi, how does this concept of explainability, which Dr. Vishal explained, bridge the trust between humans and machines?
Right. So see, trust in AI is complex, right? I mean, we are talking about humans trusting a technology. So there are a lot of other aspects involved in driving trust with us, among us, right? It's more than technology, but technologically speaking, the trust in any AI system can only happen if these following 4 or 5 things works for any AI system. One is any AI system or a model needs to provide consistent performance. Okay, that's one. And second is, of course, it needs to be transparent and interpretable for the users to trust the system. But at the same time, it needs to be safe. It needs to be unbiased. Right? Many times we have seen a lot of AI applications tend to be biased. So they need to be safe and they need to be unbiased. At the same time, the security threats for AI systems are increasing, right? Where the AI systems can be easily manipulated with external attacks. So hence the models also need to be secure. When all these things comes together, I think the human user will be able to take accountability of this model. That's very important because AI systems tend to be successful and failure, but the human users need to be accountable, and the informations about the model need to be traceable. Now, if you see, if this is what is required to drive trust, XAI is one part of the puzzle, but it is a very significant part, I must say. Right now, to your question that how XAI bridge the trust between humans and machines, I think as Vishal explained, XAI is a set of techniques and methods which are applied on top of AI models, right, to help human users interpret about these model decisions in the language that they understand. We need to take a pause here and try to understand how we typically understand, how we humans typically understand any concept, right? Like if I have to understand an event, I would be asking a series of questions like why this event occurred, why not this, what if something like this has happened, right? So I will have series of questions which are various tools that we use in order to understand any event. While with XAI, the effort is really to generate this required information from existing AI models in order to answer these kind of questions, right? Which means that the responses to these questions needs to be sufficient, it needs to be intuitive, and it needs to be complete in order to drive trust with the users. right? And at the same time, as I said, the complete trust is only possible when, along with explainability, the models act very fair, the models are safe and secure, and they are managed continuously.
So now that we get the definitions of explainability right, there's a word that I often hear when we talk about explainability, interpretability. So Dr. Vishal, I believe it does not share the same definition. So what is the difference between interpretability and explainability?
Yes, Basan, you are right. So in the context of machine learning and artificial intelligence, explainability and interpretability are often used interchangeably. So while they are closely related, it's worth nitpicking or unpicking the differences. So if only to see like complicated things, then can get once you start digging deeper into machine learning systems. Interpretability is about the extent to which a cause and effect can be observed within a system, or to put it another way, so it is the extent to which you are able to predict what is going to happen given a change in the input or algorithmic parameters. It's being able to look at the algorithm and go, yes, I can see exactly what's happening here. On the other side, explainability, meanwhile, is the extent to which you can understand the internal mechanics of the machine or the deep learning model or any other machine learning algorithm that you are using. So the extent to which the internal mechanics of these models can be explained in human terms. So it's easy to miss the subtle difference between interpretability and explainability. But consider it like this: interpretability is about being able to discern the mechanics without necessarily knowing why. And explainability is about being able to quite literally explain what is happening with your machine learning model. So that's the very subtle difference between interpretability and explainability.
I also like to add a couple of points here, Basan, with respect to this. I think it's also important to understand not all AI models are black box model. So that means there are white box models as well. Typically, the white box models are very simple, but the outcomes are interpretable. You can really understand the mechanics of the model, right? But these white box models are not really robust. They fail to understand the complex patterns in the data. Whereas the black box models, on the contrary, can understand the complex patterns in the data, but the outcomes are not really interpretable. So whenever we talk about XAI and the concept of explainability, we typically talking about applying these concepts on black box models to make it more explainable and make it more easy to understand.
Yeah, thank you, Zabi and Dr. Vishal, for clearing out those definitions. And I want to remind our viewers that there will be a quiz at the end of this podcast series. And so stay tuned to win exciting prizes. So coming back to our topic, Zabi, when we talk about explainability, most of us assume post-modeling explainability, where there is a model already developed and we need to extract explanation. But how can we apply principles of explainability to the entire development pipeline?
Right. I think we need to first understand there are various different types of explainable AI, right? I think broadly there are 2 or 3 types. One is the global explanation. It is designed to provide explanation at the model level, right? At an aggregate model level. So let's say, suppose if a model is predicting something with certain accuracy, let's say 80% accuracy, with global explanation, you can try and understand what are the factors or what are the features which are more important behind this predictions, and this helps you to understand that how generally the model would make a decision on what variables or what features it will give more importance and less importance. That is global explanation. The second type is a regional or local explanation, right? These are designed to provide explanations at a smaller subset level or at an instance level, right? Like if a model has predicted a certain customers to be default, you can seek explanation for that customer, why the model has predicted him to be a default or non-default, whatever the case may be. Also, I think we already talked about explainability and interpretability. You can, I mean, it provides you certain tools to help you understand like what features are important for predictions, how each feature in the model is contributing for that prediction, right? What I mean by that is sometimes the features, they contribute like by themselves, which we call it as unique contribution of the features. Sometimes there is also a shared contribution of the features, right? The features will come out better. They will have higher power of explainability, especially when they are included along with the other features, right? That is the second tool. The third can be to help a user understand the what if scenarios, right? What if this feature is removed or added something else? Or what if the value of this feature is not this, not that, right? So these are some of the tools which helps the user to not only understand the underpinning of the model, but also understand its outcomes better, its decisions better, right? Now, we know that in ML lifecycle, if you want to apply or use XAI, it's extremely useful at 3 stages, I would say. First stage is, let's say, the training stage or a prototyping stage, where you are training your models on the data. And here the XAI can be extremely handy to evaluate your model, especially to make sure that the model is making a business sense. In other words, the model is learning the patterns which are aligning with business rules, which are aligning with domain knowledge. So here is where you typically tend to use global explanation, right? The second stage could be decision intelligence stage. Any AI model or a system tend to be inaccurate, right? There will be certain scope for uncertainties, maybe 2%, 3%. You will never have a model with 100% accuracy, correct? So when the models are uncertain, you can use regional and local explanation in order to understand these uncertainties better, right? Like, for example, if there are false positives or false negatives, you can make use of these, the regional explanation or local explanation in order to really understand why the model is making false positives or false negatives. Then one can build the humility rules, one can build the business rules in order to prevent the costly mistakes of AI. Sometimes when the model makes false positives and false negatives, it's an extremely costly mistake for the businesses. So you can make use of these tools to really handle these problems better, right? Lastly, of course, we all know that explainability is extensively applied on model once the models are deployed. So model management is a core area to maintain the model's stability and performance over a period of time. And here XAI can be extremely useful as a diagnosis tool, right? Because once you put the model into production, the models tend to deteriorate. There will be a decay time for the models. So when that happens, you can use XAI tools to understand why the models are not making sense, right? Why the decisions are going off. And if there is a biasness in the model, then you can use XAIs to understand where there is a bias, where there is a biasness and what you can do about it. So it can be used more as a diagnosis tool at the stage of model management. Yeah.
Yeah, thank you, Zabi. I think that's an interesting point of view. And my next question is for Dr. Vishal. And as data professionals, we try to teach models or systems from past data. And we use metrics like accuracy, precision, recall. And are there any similar kind of metrics that we can use for explainability? Or how do we approach measuring how good a system in terms of explainability?
Thanks, Pasan. I think so. That's a very interesting question because but to understand like the kind of metrics which are used to evaluate these explainability techniques, we need to see what kind of explainability techniques which exist in literature or in practice nowadays in industry. So there are different type of techniques such as and I'm talking about like post hoc explanations of the models. I'm not talking about the inherently explainable models such as like logistic regression or decision trees. But for post hoc explanations, like you are using techniques such as like feature importances and Shapley values, or you are building surrogate models such as like surrogate decision trees and surrogate random forests. Or you are using some surrogate techniques such as Lime or K-Lime, these kind of techniques as well. So the metrics also depends on the kind of techniques that we are using, on the kind of techniques we are using for the post hoc explanation. For example, if you are building a surrogate decision tree, so just to explain a bit further, like surrogate models are like simpler models which try to mimic the behavior of the actual complex model. For example, if you're using a deep learning model, then to explain the behavior of deep learning model, you build a surrogate decision tree models, which tries to mimic the probability curve of the decision tree model. It tries to mimic the output behavior of the decision tree model. So, and using this surrogate technique, you obtain a very simple decision tree model, which is able to explain the complex deep learning model in a simpler rule-based, decision-based, tree-based rules to the business user. So, but when you are using the surrogate models to mimic the behavior of this deep learning model, then the metric that we have to use is how accurately this decision tree, this surrogate model is mimicking the behavior of the complex model. So that's where like accuracy metrics such as like R-square or RMSE, these kind of metrics can be used to determine the accuracy of these post hoc explanation models. But if you're using techniques such as like feature importances and like Shapley values, then sometimes the techniques such as like insertion or deletion are used to evaluate the accuracy of these explainability techniques, such as, so for example, for a particular model, you are given a feature 1 as the highly important feature. Then something you can do is you remove that feature 1 from your data set, and then you try to see how it impacts the model performance. So that's how you can evaluate the performance of that, the feature importances or Shapley values techniques which are used here. So similarly, also like you have to use the techniques to evaluate the robustness of these techniques. Techniques such as Lime and Shapley, they're also, because they apply perturbations on the complex models, so it's important to evaluate like what kind of perturbations and what kind of noise insertions like impact the quality of explanations which are coming out of these models. So with respect to the stability of these techniques, also there are some metrics which are used to evaluate like this particular technique such as Lime or Shapley is stable with respect to like noise or perturbations in the data or not.
Thank you, Dr. Vishal. I think before we move on to our next question, let's have a small 5 minutes break. And I want to remind our viewers that there will be a quiz at the end of podcast, and so stay tuned to win exclusive prizes.
This is a new era, and it's transforming how enterprise software is being constructed and deployed. Organizations are mobilizing to leverage modern applications, which are now the fastest growing storage workloads. But today's data centers still need to run a mixed workload environment with traditional enterprise applications. Is it possible to modernize for today's application-oriented workloads, plan for tomorrow's analytics-heavy applications, and still continue to meet all of your service-level agreements? Traditionally, all-flash arrays are considered good candidates for workload consolidations. However, modern applications coupled with the need for future-proof storage leads to requirements that conventional all-flash arrays have trouble delivering. In addition, to maintain service-level objectives over time, storage platforms need to autonomously learn from patterns in the data. And to make matters more difficult, when there is higher workload consolidation on a single storage array, there's an increase in fault domain risks. So, when choosing the right storage platform for your mission-critical applications, platform resiliency is critical. Dell EMC PowerMax is a future-proof enterprise storage platform that is architected with an end-to-end NVMe design. It offers comprehensive storage functionality and the proven availability of the Dell EMC flagship VMAX arrays. PowerMax fundamentally changes the way mixed workload environments are managed. bringing higher performance, more efficiency, and ease of use. The array uses a variety of artificial intelligence techniques to learn from the workloads themselves. Machine learning allows the array to maintain service quality throughout a shifting workload mix. It will also optimize data placement between NVMe flash and storage class memory drives. Built-in artificial intelligence will automatically recognize I/O profiles and move data in real time to the appropriate media types. It's designed to cost-effectively support traditional and modern analytics-powered applications, all within a single PowerMax array. This means as your organization begins its digital transformation, you can benefit from a wealth of big data by employing artificial intelligence to optimize your operations and your business. And with the ability to analyze and predict in real time, you'll be joining the ranks of businesses that are augmenting human decision-making, modeling investment risks, detecting supply chain issues, and analyzing security intelligence. Modernize your storage infrastructure with Dell EMC PowerMax and make faster, smarter decisions today to stay ahead of your competition tomorrow.
Welcome back to the third episode of our podcast series, and today's topic is Explainable AI, and we are joined by two special guests, Dr. Vishal Sharma and Zabi Ulla. So welcome back our viewers. So far we have been talking about the theoretical aspect of Explainable AI. How can we really use Explainable AI in an organization that can be beneficial to the end users? Zabi, Mr. Zabi.
So is this question to me?
Yes, Mr. Zabi.
Sure. Okay. I think we partly we have answered this question, especially to the end user, how they can use XAI to understand about models decision, right? So they can understand what features are important, and having one feature versus not having other feature, what is an impact. We also understand if the AI decisions go wrong, especially in the case of false positives and false negatives, how we can use local explanation, which is the part of the XAI techniques, local explanation techniques to understand for that particular customer or for that particular instance, why the decision has gone either in favor or not in favor. But I wanted to give slightly larger perspective to this, like how explainable AI helps an enterprise, right? Because so far we talked about how it helps an individual user or an individual data scientist. So let's talk a little bit about how this can help an organization, how this can help an industry or enterprise, how it can help the businesses to transform in their AI journey, right? So I think one thing is very clear that lack of model explainability uh, presents a risk to any industry, right? Uh, I think to contextualize this a little better, you can think about healthcare because the stakes are very high in healthcare, bioinformatics, and in these domains, using AI models which are not explainable presents a very high risk, right? Especially if the model is presenting a recommendation on, let's say, patient care, and it is not explaining the reasons behind that decision. It's extremely difficult for the ecosystem to adopt such AI models. We can also talk about the same similar situation in financial services. Regulators may question the financial institutes about making a particular decision on, let's say, on lending, right? So practically speaking, XAI helps not only answer all these questions, but it also helps the businesses while they are at different level of their maturity transformation, right? So one is let's establish this, that it's easier for the users to trust a system which is transparent, right? Because user can be accountable now once they understand the underpinning about the models and the outcomes of the models. They are ready to take accountability of AI model, and this is very important in the AI governance framework. Second thing is when there is a bias in the data, see, bias is quite natural to have in the data, and this biasness will eventually flow into the AI models. But XAI can be used as a tool to understand and identify this biasness in the early stage of model lifecycle, right? I have also seen in my experience that especially for the businesses who are starting starting to build AI models, starting to use AI in their day-to-day businesses, starting to make AI investments, they can use XAI to avoid what we call it as a investment wastage in the models, because not all models are going to give fruitful results to the businesses. Now, how to identify what is the right set of models that I need to have at this point of time? I think XAI can really be of help there, right? And even in the matured organizations, the organizations who are extensively using AI systems in their business processes, these matured organizations are subjected to high level of scrutiny, right? And XAI becomes extremely useful tool to perform the model diagnostics so that they can continuously monitor the decisions of the model, and then they can put some guardrails whenever the model fails. So XAI can act as a diagnosis tool there. Last but not the least, explainable AI really matters for any businesses because the legal regulations are coming very high, very aggressive on defining the right to explanation, especially when there are model decisions in play. Best example that we can think about is GDPR for now.
Thank you, Zabi, for the lovely input. And Dr. Vishal, I want to move to a specific industry. Since you have worked in so many industries, what are some of the practical use cases you encountered in your field of work?
Right. Actually, I mean, that's a good question because now in industries, like in most of the industries, like these regulatory requirements are being put in place. So maybe I'll give example of a financial industry. That's where I worked. And I'll give an example of healthcare industry as well. That's where I'm working with some of the customers at H2.ai. For example, talking about these regulatory requirements, for example, in Singapore, the Monetary Authority of Singapore, the MAS, which is the regulatory body in Singapore for financial entities, it introduced a new feed principles to promote like responsible use of AI and data analytics. So these set of principles are put in place. Similarly, in healthcare, United States FDA, they provided some guidelines on the machine learning, use of machine learning for medical devices, and these guidelines came in June 2022. Similarly, for even for drug discovery, etc. So many of these use cases different regulatory requirements are being put in place. Explainable AI plays a very important role. For example, in finance, when it comes to understanding the nature of the model, or understanding, as I mentioned, understanding the fairness and biasness, if the model is fair or is biased with respect to some sensitive attributes or not. So all this has become very important. So explainable AI techniques, they help to help you to firstly vet the model. For example, if the end user understands that what kind of features are being used in making the decision of the model, what are the important features which are being used by the model to make its decisions, then it helps to bring the confidence in the end user. For example, if coming to finance, if the machine learning model is used for anti-money laundering use cases, or for money laundering detection use cases. So in that case, like if the model is saying that the key feature in this particular model is the ID. So in that case, or date of some transaction, then probably the end user will think that, oh, probably the model is just using some irrelevant features. But if the features which are being captured are features like transaction amount, or the geography of transactions, for example, if they are international transactions, or if there are transaction cycles which are there in the with respect to that user, then then there's high probability that the model is working with respect to the expectation of the end user. Similarly, coming to the lending use case, which Zabi mentioned, that in this use case as well, it's very important to investigate like the model is fair or biased or not. So that's where also, for example, for lending applications, and if the model is used for underwriting use case, then if the model is using features such as race or gender, then the model is obviously like biased, and it's not fair. And in that case, it's very important to investigate the fairness and biasness of the model with using techniques such as disparate impact analysis kind of techniques. So that's where also explainable AI techniques are being used. Then also, like Zabi mentioned about the what if scenarios, these kind of simulations. So these techniques also help to bring more confidence, like in using machine learning models. For example, again talking about the lending use case, if a loan for a particular applicant is denied, and the important feature for that particular customer is identified as the salary of the customer. So in that case, these explainability techniques also gives you some recourse actions. For example, if this customer increases salary by 50K per year, in that case, the probability of the loan being approved increases from like X% to X plus some extra. For example, it moves from 70% to 90%. So that's how these explainability techniques are being used in finance sector. Then in healthcare sector is very important. There was a very famous example where, for example, about the lung cancer prediction, where the doctors use the X-ray images to try to detect the lung cancer, and the accuracy was around 78% by like a manual investigation. And there was a model which was trained, which had the accuracy of like 88%. But when the doctor used the model without the interpretable components of the model, then the accuracy of doctor plus the model was only moved from 78% to 82%. But when the doctor was provided the model along with the important features of the model, such as the genetic conditions, the family risk conditions, chronic health conditions, then the doctor had more confidence in the model, and the overall accuracy of the detection of lung cancer moved from like 78% to 93%. Right, so that's why interpretability plays a very important role, like in adoption of this AI and machine learning models, be it in finance industry or healthcare industry. There are many other industries where it's being used, but yeah, these two industries are quite crucial when we're talking about explainable AI.
Yeah, thank you, Dr. Vishal. I think it finally breaks down to confidence of the users. And Zabi, so the conventional machine learning systems have their unique set of challenges. Fairness and biasness and safety are some of them. So I'm sure there are a unique set of challenges for explainability as well. So in your point of view, what are some of the challenges we have to face to solve explainability AI?
Yeah. Firstly, I think explainable AI is still evolving, and it is fast evolving, which means that the challenges that we mentioned today may not exist tomorrow, right? But one important thing, mostly from a end user or a business perspective, that how they want to evaluate XAI. One is the explanation that XAI provides. It needs to be intuitive, right? It should make sense to them based on their own beliefs and understanding of the domain. It needs to be complete, right? I mean, many a times explanation, because as you can understand, the models capabilities are limited to the data capability, right? And if some necessary features are not captured in the data, then obviously model will not be able to explain using those features. So, but the business expects those explanations to be complete. Okay. The third can be the usefulness of the explanation. Explanation provided by the models needs to be useful so that they can be acted on, right? It should not be only theoretically correct, but it should also be practical. So see, these are some of the principles I believe that the businesses will, or the end users will always use on explainable AI. Now, with that, I want to highlight also the fact that explainable AI outputs are complex today, right? Of course, we have various different tools. It has been this lot of continuous effort being put on this domain, but still the explainable outputs are very complex, right? So it's important for XAI to align with some of the principles that I just highlighted. Okay. Now that being said, some of the key risk of XAI is one, the complexity, which I already talked about. It's also, in the space of complexity, is also expected that XAI to present the outputs in a human-friendly language, right? And as I mentioned, this challenge, there are a lot of techniques which are being built in order to explain this explanation in a very easy to consume manner. Like for example, Angular is something that I recently came across, which basically generates the explanation and try to communicate in a very simple English, right? So XAI is complex, and we need the techniques to produce the human understandable outcomes. So that's one of the key challenges. The second is the variety of XAI. Right? There are too many methods and too many techniques. And as I said, XAI will evolve, which means that it will add more methods and more techniques, very specific to frameworks, very specific to ML techniques, also very specific to data context. For text, there would be a different techniques. For images, there would be a different techniques. For tabular data, there are different techniques. There's too much of variety. Sometimes it creates a lesser application, especially in the business context. So, and the third risk that I see is also the breach of confidentiality, right? See, there are some models which are supposed to be safeguarded, supposed to be secure, right? Now, explainable AI can create a security risk by revealing the information about such models, right? Now, confidentiality is not a threat for all the use cases or all the AI type of models, but there are certain AI models which are supposed to be secure, which are supposed to be safeguarded. XAI on those, applying XAI on those will create a security risk, right? So what I would say is the XAI need to be, yes, today XAI is model specific, but it also needs to be model agnostic. One other reason that I can think of is the unreasonableness, right? Because as I said, the AI system's capabilities to take a decision is limited by the patterns that it identifies in the data and what it is, its capability to learn from the data. And XAI also will hold that limitation because it is working on top of that model. Yes, there are some techniques, as Vishal mentioned, where the idea is to create the surrogate, simpler model in parallel to the complex model, whereas this complex model will do the job of predictions with very high accuracy. whereas this parallel surrogate model will help explain those decisions, right? So these kind of approaches are coming into play, but XAI at any point of time in the day, it will be limited by the model that has been built, by the data that is available for the models to learn from, right? And lastly, I think XAI also need to be business context specific, right? So a lot of industries are expecting XAI to be very specific to their industry. Like healthcare need AI models, also XAI models to be built specifically for their domain. Because a lot of times, like if you take an example of deep learning or neural networks, they are designed very generically to understand the images, but what about the images very specific to healthcare, the X-ray images or the diagnosis images? So, so there is an expectation from the business that it needs to be context specific. That's also one of the key challenges that we need to work on XAI.
Yes, Zabi, thank you. So, Dr. Vishal, what's your take on this? As a practitioner, what is your approach to overcome these challenges?
Talking about challenges, just like to add to Zabi's explanation. So there are still there are a lot of challenges. There's a lot of work going on in the field of explainable AI. There are many techniques that we use, right, for explaining a certain model. So, for example, even for tabular data, we can be using techniques such as permutation feature importances. Then we are using Shapley values. Then we are using partial dependence plots or like K-lime kind of techniques. So sometimes there is like conflicting explanations which are being generated by these techniques. So that's one of the challenges. Then of course the interpretability or easy understanding of these techniques. These techniques such as Lime and Shapley, they themselves are complex in nature. So we are trying to explain these models to the end users, but again using some complex techniques. So that interpretability of these techniques itself is a challenge in XAI. Then of course the stability of the explanation is also a key concern. So if you are using techniques such as Lime, as I mentioned earlier, these techniques are vulnerable to like adversarial attacks because this depends on like perturbations and it has been proven that if the perturbations do not follow the distribution of the data, then it can affect the stability of these techniques. Similarly, when we're talking about like image, when you're trying to do some image classification tasks, for example, you're trying to detect like cat versus dog kind of images. Then we are building a complex deep learning classification models. So these are also like vulnerable to scaffolding attacks, and where user can do very minute changes and manipulate these images and then it will change completely the explanation of the explanation which is coming out of these explanatory techniques. So there are still many challenges, and like a lot of research is being going on. So there are techniques which are being worked on, for example, to address the problem of the perturbation of vulnerability of Lime techniques to the perturbation in data. Researchers are coming up with techniques such as Bayes Lime or Bayes Shap. These kind of like a Bayesian techniques which give you a confidence of like a level of confidence, like you can think of it as a confidence interval on these techniques. So which helps like in like using these explanatory techniques with certain level of confidence by the end users. So yeah, there are many challenges still, and there is a lot of work going on. Yeah, but there's still a lot of work needs to be done. That's for sure.
Yeah, thank you, Dr. Vishal, for the lovely input. And as we head towards the end of our podcast, I would like to remind our speakers, viewers, that there will be a quiz at the end of our podcast. So stay tuned to win prizes. And coming back to the topic, Zabi, organizations like EU are already demanding the right to explanation from these AI systems. So as responsible professionals, how do we achieve human-centered AI system designs with explainable AI?
You said organizations like EU, European Union.
Yes.
Yeah. Okay. So let's understand this. I think Vishal brought a very right point that we are using machine learning to solve the challenges of machine learning. Um, yes, so let's see if there is a question comes up from people on this, but I'll wait to that. I think what we let's understand this. We people, we humans, we have our own internal models to interpret our surroundings, right? We have our own belief systems, right? But if we want to use AI systems in our day-to-day lives, they are expected to work at minimum to our level, to that level, right? So, which means that we need to build the models which can be tested and verified as either accurate or inaccurate representation of the world that we believe in, right? So, I think this is where the human-centered AI concept comes into play. Uh, uh, in my experience, and I think it helps design. It allows the AI systems to be designed around these end users' needs and expectations. Right? How can we involve the users in the loop of the machine learning process? Right. So it's also about how can we include those constraints based on which we typically take decisions into the machine learning process in order to build the successful AI applications. Right. That's where the real success of XAI comes, especially when the human is involved in the loop of developing the model. Right. And I think if you really want XAI to evolve, it evolve in order to help the users to drive the trust. It is very important to keep that user in the process of building the machine learning model. I think that's how the human-centered AI system, along with explainable AI, can contribute to driving trust.
Thank you, Zabi. So lastly, Dr. Vishal, what will the future look like with explainable AI?
Right. So as I mentioned, like there is a lot of work going on explainable AI because this has been, so last decade was about like the deep learning revolution and the machine learning revolution, but now there's a lot of work going on in explainable AI so that these models are being adopted by the industry with a high level of confidence in these techniques. So there is a lot of work going on, firstly in the post-hoc explanations and in surrogate models. So there are a lot of methods which are being worked on for providing more reliable post-hoc explanations and like and a lot of limitations of these models, like in terms of the model robustness, in terms of like these experimental techniques, sometimes they also absorb like the unbiasedness of the model or the unfairness of the model. So these techniques sometimes they are inherently biased and unfair as well. So how to deal with that problem? There's a lot of work going on in that. Then adversarial attacks in certain applications, certain use cases, adversarial attacks are a point of concern. So how to make these explanatory techniques robust enough so that their adversarial attacks are so they are not able they're able to absorb the these adversarial attacks, and they are still able to generate like reliable explanations even when certain user is with malicious intentions tries to manipulate with the data. So I can say that there's sort of work going on in the area, in the research. Then, as Zabi mentioned, also that these because these models are very complex, so how to provide this explanation to the end user in in a natural language form, in the text form, or in a more visual form, so that they very easily understand these explanations provided by these techniques. So there's some work going on in that area as well. And with the evolution of these large language models, like GPT models or BERT models, so these interfaces and these tools are possible now. And new benchmarks are being created for model understanding. So yeah, a lot of exciting work going on right now.
Yeah, thank you, Dr. Vishal, and thank you, Zabi. I think those are the questions we have prepared, but we do have some questions from our live audience. And before I move on to those questions, I would like to remind our viewers on the quiz. And so the question for the quiz is, which of the following considered as a benefits of explainable AI? So option A would be reducing cost of mistakes. Option B, reducing impact of model biasing. And option 3, responsibility and accountability. And option 4, code confidence and code compliance. And the last option is all of the above. So let me repeat the question again. Which of the following considered as benefits of explainable AI? Option A, reducing cost of mistakes. Option B, reducing impact of model biasing. Option C, responsibility and accountability. And option D, code confidence and code compliance. And option E, all of the above. To answer the questions, we have sent a link to your email. You can submit your answer via that link. So Zabi and Dr. Vishal, we do have some questions from our audience. So my first question goes to Zabi. So is there a global standard defined to ensure or measure the trust in an AI environment?
Yeah, so there are a lot of standards available to ensure there is a trust in AI environment. A few things that comes to my mind is ALTAI. It is an assessment of AI systems from European AI Alliance. It's very comprehensive. It is basically a manual assessment that one can do on any AI system, and the responses to that assessment, which is in form of questions, will help you ensure there is how much of trust that you can have on this model, on this AI system, and what you can do to improve the trust, right? Or how you can sustain the trust over time. Of course, there are a lot of companies like IBM, AWS are coming up with their own research work in this domain. It is one of the AI trust is one of the hot topic. It's one of the top trends in 2023 from as per Gartner. But yeah, I mean, there are many such institutes who are issuing guidelines for authorities to make sure that the models are trustworthy. The other part of the question, I think it is to measure trust in AI environment, right? I think the research is on coming up and trying to quantify the trust in the AI environment. But believe me, it's very complex when we are talking about quantifying trust, right? So I think we have put some efforts at Subex along with ADL and other people in the TM Forum Catalyst projects, where how we can quantify and measure the trust in AI systems. We have currently looked at the technology aspect, but as I also mentioned in my conversation, that trust is much more than technology. Because every time the technology has evolved, it has created social divide. It has influenced the sociological and cultural aspects. I think all these needs to be considered while we are trying to quantify the trust in the AI system. And at the same time, I also, what is feeding this research, right? I think we are trying to learn from the mistakes. Within the industry, all the major AI incidents, wherever they happen, I think there is a database where we are tracking all these AI failures and trying to understand that why some systems have failed, right? And these incidents are our inputs for researching and coming up with certain guidelines and frameworks for the measurement of trust. I hope I have answered the question.
Yes, thank you, Zabi. So my next question goes to Dr. Vishal. So one of our viewer wants to hear the view on causation and versus explainability. So Dr. Vishal, and he has mentioned that as soon as they present the local explainability to clients, they tend to interpret them as into causation. So what's your view on that, Dr. Vishal?
Right. Actually, causality, that's a very good question. So causality is also one of the area under this whole umbrella of explainability, where a lot of work is going on. And the reason exactly being that, so techniques such as feature importances or Shapley values. They provide like transparent correlations picked up by the predictive models, or these patterns which are picked up by these predictive models. But yeah, sometimes the end user make the assumption that that we are making they interpret this predictive model as causal. And I mean, these features are being causal while this decision is being made by this predictive model. And these interpretations are actually unrealistic. So causality is a new category of machine learning intelligence that is that discovers the reasons about the cause and effect. Even researchers such as Yoshua Bengio, he's a deep learning pioneer. He's also working on that. He recognized that causality is very important for the next step of progress in machine learning. So there's sort of work going on in the field of causal AI, which produces intrinsically interpretable box models and which provides reinforce the trust in these models. So there's sort of work going on. Definitely, there's a combination of techniques such as Shapley values and partial dependence plots. They can be used in conjunction to provide causal explanation to the end users. But yeah, of course, some work in the area of causal explanations is also required. In many use cases, manufacturing sector comes into mind when you think about causal features. Yeah.
Thank you, Dr.
Can I add to this person?
Yes.
I think it's a very interesting question. It is a question that entire ML community is dealing right now. Causal machine learning based on causality is entirely different paradigm, right? Because the current algorithms that you study today, they work on identifying the white noise in the data. In other words, it tries to identify the co-occurrence of patterns. In simple words, you can say it is entirely based on correlation of the events. And on such machine learning systems, even when you apply explainable AI, it tend to give you mostly the indicators. Yes, indicators can be causal, cannot be causal, but that is subject to human interpretation. Okay, but the important point here is the machine learning is trying to understand the patterns, let's say based on correlation, putting in simple terms. So there is a lot of focus on how can we make machine learning to identify causations in the data and then bring that into the decision-making process, into the machine learning decision-making process. There's a lot of interesting work going on the causal, in the titles of causal machine learning or causal artificial intelligence. I would strongly recommend the person who have asked this question to look at some research work on this, especially from Julia Pearl, where how we can leverage the techniques like Bayesian in order to build the causal machine learning, right? It's possible, but I think it has still not come into the main paradigm.
Yes, I think again, like a combination of techniques such as we're talking about Shapley values, but when we combine with partial dependence plots and also what if simulations, the sensitivity analysis techniques. So when you try to combine these, so for example, Shapley values are saying that certain feature is important, but when you apply the sensitivity analysis on this particular feature and then try to interpret the model, then that provides you some kind of cause and effect kind of explanation. So that's why I was saying that the combination of these techniques actually help you provide causality analysis on your model. Yeah. Sure. Thanks, Zabi, for adding to that.
Yeah. Thank you, Zabi, and thank you, Dr. Vishal. I hope we address your concerns. And next question goes to Zabi. So you mentioned that there are two kind of model, white box models and black box model. So will black box model no longer exist in the future?
No, it's difficult to say that. I would say otherwise. There will be mostly black box models in future. I think, see, why the black box models are used today, they are used today because in most of the AI application, the focus is only on accuracy, which is fine. Like if you just want your AI system to recognize a face or recognize an image, you don't need explanation, right? There are a lot of applications where expectation for explanation is very low. Expectation for interpretation is very low. In those cases, people started using black box model because the black box model has those capabilities to comprehend the complex patterns in the data. Keep in mind that on the other side, the volume of data and also the variety of data is increasing, right? So which means the patterns in the data are becoming very complex. So you definitely need black box models. They are not going to go away. The very reason that we are talking about explainable AI is because most of the applications that we see around us are black box models. Hence, there is a need for explainable AI to explain about this black box models wherever it is applicable.
Can I just add to that a bit, Hassan?
Yes, go ahead.
So actually, yeah, as I agree with Zabi. So black box model, there'll be actually more black box model will be more used in practice with the advancements in explainable AI. So the objective for explainable AI is to make this black box model read as a glass box or white box models. So when there's a lot of research going on, so when you have proper metrics in terms of faithfulness, accuracy, robustness, and fairness and biasness, all these metrics are properly placed, and you have proper benchmarks in place. And then once these explanatory techniques, they cross that particular benchmark, then black box will be used, black box models will be used, you can even say without the need of explanations. That's my take on the future of explainability.
Okay, Vishal. So, lastly, we have one more question for Dr. Vishal. As you explained from the lung cancer example, we often experience a similar trade-off between the model performance and model explainability. Any breakthrough on the research community for this issue?
Yes, so there's definitely a trade-off between interpretability and the accuracy of the models. So generally, more accurate models are like nonlinear in nature, and they are a little bit more complex in nature because they are trying to capture some nonlinear patterns which exist in the data. So the research which is going on is in providing this post-hoc explanations. So this post-hoc explanatory techniques, there's a lot of work going on there, talking about surrogate models, which are rendering these complex black box models as white box or glass box. But yeah, there's a lot of work still need to be done in terms in the area of stability and fairness, biases, and yeah, faithfulness of these explanatory techniques. Yeah, once we cross the benchmarks in those areas, then like even the black box models, the complex models will be accurate as well as like interpretable by humans very easily. So that's the kind of work going on.
Yeah. Once again, thank you, Zabi and Dr. Vishal. Those are the questions we received from our audience, and we hope we address your concerns out there. So, and I want to remind our viewers on the question for the quiz. It will be on the screen as well. Which of the following considered as a benefits of explainable AI? Option A, reducing cost of mistakes. Option B, reducing impact of model biasing. Option C, responsibility and accountability. Option D, code confidence and code compliance. And last option, all of the above. So we have sent a link to your email. You can submit your answers via that link, and we will be announcing these winners in the AI forum scheduled on 18th and 19th of November. So let me repeat the question again. Which of the following considered as a benefit of explainable AI? Option A, reducing cost of mistakes. Option B, reducing impact of model biasing. Option C, responsibility and accountability. Option D, code confidence and code compliance. Option E, all of the above. So once again, thank you very much, Zabi and Dr. Vishal, for joining with us today despite your busy schedule to share your valuable insights, and it was lovely to hear your thoughts as industry experts.
Thank you so much, Prasanth. Thanks, Vishal. Thank you so much.
Thank you, Prasanth.
Thank you.
Glad to be part of this.
Yeah. So winding up for today, don't forget to like, subscribe, and get notified for the upcoming events. And see you soon with the next episode of our podcast series, where we try to tackle how blockchain, Web3, NFT, and AI will bring new value to business, which is scheduled for tomorrow. Thank you once again, and have a nice day.
Humans are doing incredible things with data to change how we think, solve problems, and innovate. We're sending people into space to explore new horizons. NASA is generating over 12 terabytes every day from over 100 active missions and thousands of sensors. We're unlocking genome sequences to combat viruses and disease. A single genome sequence with a modest sample size can take up several terabytes. We're using AI, machine learning, and deep learning to create smarter systems and self-driving cars. The problem is that traditional storage systems just can't keep up the performance and capacity requirements for these GPU-powered workloads. This produces inefficient silos, requiring a lot of different touch points and unexpected costs. When you are capturing, creating, and using massive amounts of data, you need the data to be stored and processed fast, while being accessible anywhere it's needed, which is why we are expanding our Dell EMC PowerScale all-flash offerings to include our new blazing fast all NVMe F900 system. Instead of being spread out, data can be stored and consolidated in a data lake. With our latest all NVMe system and a best-in-class partner ecosystem, the most demanding GPU workloads and applications can be handled with ease from the edge, the data center, or the cloud. And it scales out to 93 petabytes in a single cluster, so you can innovate without limits. No matter what your needs are, we can help you from start to finish and beyond, so you can get back to innovating and driving human progress forward. Learn more today at delltechnologies.com/PowerScale. Humans are doing incredible things with data to change how we think.
curious has really helped me to land where I am today. I actually started off as a graphic designer and then moved into motion design, and I'm now a digital fashion artist. I tend to study traditional Chinese clothing and then try find a way to modernize it. I think that kind of fusion between the two is really interesting. I want to find a way to reconnect back to my roots and also share it to my audience. For me, what's interesting working as a digital artist is that there's so many more textures, so many more materials you can play around with. There's a lot of unexpected moments you can find. You could be walking in a park and suddenly something or a shape or a texture catches your eye. Technology is already embedded in my process. I'm able to connect everything into one ecosystem, which means I get to focus on the most important thing, which is the creativity. Everything that I have learned is actually self-taught from online, so there is definitely space for more digital fashion artists like myself to join. Hey guys, welcome to Streaming Thursdays. Hope you guys are doing good. I can't wait to show you guys what I have been researching today. Let's get into it. Usually what I would find, especially during my live streams, is that maybe I'd be showing a technique. Maybe I don't know a certain thing or how to change a color or how to scale something, and someone in the comments will say, hey Steph, why don't you try this? I like to show the raw failings of my learnings.
Damn it. Not the right program.
Oh my god. Oh my gosh. Find RS color or just color correct. If you link that all up to your surface, so this RS material blender, connect it to your output surface, you should get something like this, okay? As I get older, I have a better sense of myself, and I feel like right now I'm getting more and more comfortable with my British Chinese identity. If anyone hears about my story or sees my work, at least they'll understand a little bit about my perspective and my character.